Okay, guys, today we're going to be looking at a way to derive a new equation through graphing. I'm going to start with a distance and a velocity graph, and what we're going to do is, we've already graphed what constant velocity looks like. Now what's it going to be if we change the velocity? So we'll start with zero velocity, sorry, a little below the doc cam, and we're going to go every second 10 meters per second faster. So in the first second, 10 meters per second. In the second second, 20 meters per second. In the third second, 30 meters per second. And in the fourth second, yes, you guessed it, 40 meters per second. That will look like a nice straight line on the velocity graph. There we go. Now on a distance graph, it's going to look a little different. Since we're increasing our speed, the distance coverage should increase, and it's going to be exponential. So in the first second, our object accelerated from 0 to 10, so the average speed was actually 5 meters per second, which means it only went 5 meters in that first second. Now that may seem a little counterintuitive, but the reason it's only 5 and not 10 is because we only went 10 meters per second at the very end of that first second. In the second second, we're going to go 10 to 20, which is an average of 15. So I'm going to add 15 meters to this, or put us up here at about 20 meters. In the third second, so between 20 and 30, that's going to be 25, and you can see that this is going to start to increase pretty drastically. So we're up here to 45 meters, and in the fourth second, I'm going to add 35 more meters. That puts me way off the page up here at 80 meters. So I'm just going to put an arrow up there. So when I graph those points, you can see that instead of a nice straight line, I'm going to get this beautiful exponential curve. Now to find distance traveled, on our position or our distance versus time graph, it's pretty easy. I just say, hey, looky here, 3 seconds, how far? Go over to 45 meters. On this graph, however, if I want to find the distance traveled on a velocity versus time graph, I actually have to take the integral, or the area under the curve. And the way we do that is find the area of a triangle, 1/2 base times height. So in this particular graph, the distance traveled will be 1/2 times the base, which is 3 seconds, times the height, which is our change in velocity, of 30 meters per second. So 3 times 30 is 90. Cut that in half, and we're at 45 meters again. So that equals that.